Okay, we are official.
Lights, camera, fractions.
Yes, thank you so much.
Wahaha.
Okay. Graphing. Okay, so what we've done so far, we understand how to graph when A is 1 and when there's no B. Yesterday we learned how to graph when A is not 1, when it's bigger than 1, or when it's lower than 1. It's standard y equals x squared is standard parabola guide. Y equals 2x squared is standard parabola guide times 2. Y equals 1/2 x squared is standard parabola guide times 1/2. And the 1/2 or the 2 or whatever A is gets multiplied times the y. Right? Remember that? It's times the y. Over 1, up 1. That last thing is up 1. That's your y. Over 1 is your x. Up 1 is your y. If it's y equals 2x squared, it's over 1, up 1 times 2. Right? Over 2, up 4 times 2. Right?
Yep.
Right? So you guys understand that. So the only piece that we're missing is the b. Right? And the b makes it far more interesting. Right? It allows you to move the vertex left or right, right? So let's talk about it. So let's just remember again, we've got y equals ax squared plus bx plus c. And just one quick review. A tells you if it's smiley face or frowny face. It also tells you if it's skinny or fat, right? B moves it left and right, but it meaning the vertex. And C moves the vertex up and down, but it also does what? It tells you your y-intercept. Your y-intercept. And that's not always your vertex. It's only your vertex when there's no B. Right? Right? Otherwise, you just consider it the y-intercept, right? So today, though, we're going to start looking at what happens when there is a B. Okay? So there is well, let me think, how do I describe this? There is a formula that you have to know, and it's called the Axis of Symmetry formula, and it's one that you want to memorize. It is amazingly useful in quadratics. Okay, and this is what it is. X equals, and everybody leaves that part of the equation out, and that is a really important part of the equation. When I ask people what is the axis of symmetry, they say, oh, it's b negative b minus negative b over 2a. No, it isn't. It's x equals negative b over 2a. You want to know what you just solved for, and this tells you the formula. If you keep the whole formula, you know what it is, right? So that x is so important. X equals negative b over 2a. That is gold, right? Now, you guys all know what the axis of symmetry is, right? No matter where my parabola is on the graph, right? If my parabola was right here, I'm going to turn around like that, and that's my vertex. It's right through that vertex. There is a vertical line. We can draw that parabola very well because it's not very symmetrical. But your parabola is totally symmetrical. If you flipped this over, it would be exactly, this line would be exactly on this line. If I flipped this one over, this line would be exactly on this line. So that line is your axis of symmetry. I know the distance from the axis of symmetry over here is exactly the same distance as from the axis of symmetry over to here. Very, very useful. All right. So if I wanted to find the axis of symmetry, why would I want to find the axis of symmetry? Well, what's so special about knowing the axis of symmetry? It moves what?
So that you know that the dots are right there.
So the vertex is actually where is always on the axis of symmetry, right? So if I know what where the axis of symmetry is, I know at least my x of my vertex. Am I right? Because the x is going this way, right? It tells me how far over to go to the right or how far to the left to go. Are you, let me help you. Because this is just like too many. You got it? Okay, good. All right, great. So I need to know how far over that axis symmetry starts. Now, do I have to have 2 points to draw this line, the axis symmetry line, or do I just need one thing?
One.
What do I need?
You just need the birth.
I just need to know what x is, right? Because if x is right here, if my axis symmetry is right here, that would be my x would be over 1, 2, 3, 4, whatever. Boom. And that would be my axis symmetry, right? So, look! It tells me what x is, right? So let's try one. Let's try an example. Let's say I asked you to graph y is equal to, we're going to keep it simple for now, x squared, where a is 1, x squared minus 8x plus 10. Okay? Y is equal to to x squared minus 8x plus 10. Suddenly, we have a negative 8x. We have a bx. And we know now that the vertex is definitely not where on the graph?
Not in the middle.
It is not on the y-axis, right? It is not on this y-axis because we have a b. Now, it doesn't mean we just move over 8 to the left. You guys with me? You don't move over 8 to the left and say, okay, that's where the vertex is. You've got to follow this formula to find how far you move to the left or the right. And so, what is my a?
It's 1.
This one.
It is 1. It's the number in front of the x squared, right? So my a is equal to 1. What's my b? Right? That negative is really important. Right? You guys all see that?
Yeah.
It's negative 8 for the b, and the c is what?
It's 10.
10. Okay. So my formula is x is equal to negative b over 2a. I really recommend when you do these, write the formula every time. Because you want your formulas to go into your long-term memory. Do you guys know how that works?
Yeah.
Short-term memory, you don't bother writing it at all. Right? If you don't care about remembering it long-term. If you want to remember it long-term, keep writing the formula as you do it every time. It takes like half a second. It's like not going to waste your time, you know. And you're gonna remember. This is pencil sharpening day, apparently.
Sorry.
It's okay. We just had it sharpened for 5 minutes ago.
No, not 5 minutes.
7 minutes.
It was more like 10.
All right. So
He broke his
taking a picture.
Okay.
Okay. All right. All right. You guys understand that though? Repetition is what makes something go into long-term memory. You guys know that?
Yeah.
Repetition. God.
Gary, I'm having trouble.
It's my pencil too.
I broke everyone.
3 pencils.
Yeah, somebody give him a pencil so he
3
can
of
just
them.
use.
Here,
I have a mechanical
mechanical.
It's also mine.
Great.
Thank you.
Don't bring
Oh,
it
it's
back.
like
He's
reading
trying
black.
to like crack
Guys,
it.
this is a lecture and I've got it recording right now, okay? Thank you so much. All right, so,
5 left.
okay, Gideon, so now focus. You got your
Right.
pencil. Okay. So we have our axis of symmetry formula. You always write it. Every time you write it, you're going deeper into long-term memory.
X equals 4.
Every time you choose not to write it, you're choosing not to remember it long-term. Just so you know that, right? Right? So I really recommend you write it out. It's so easy. So that equals
8
negative,
divided by
negative 8. Negative, negative 8, right? Because that says negative, and then that's also a negative. Negative, negative 8, which means positive 8, right? Over 2 times 1. So that's really 8 over 2, which is equal to 4. Am I right?
Yeah.
So my axis of symmetry is 4. So on my graph, I'm going to go over 1, 2, 3, 4, and I'm going to put a dotted line vertically here. What do I know now about that dotted line?
That's the axis of symmetry.
Yeah, and what do I know is on it?
The vertex.
The vertex is on it. It's somewhere on that line. So if I were
Plus
going
that.
to, if I were gonna have the point, let's say the point was down here at, this was say, negative 8 or something, like right here. Let's say it was there for a second. What would be the coordinate of that?
It would be 4,
It would be 4 comma negative 8, right? let's say it was here, which was say like around 5. So what would that be?
4, 5.
4 comma 5. What's the same on both of them?
4.
The 4. So when you're solving with your axis of symmetry, you're solving for, if you have the vertex, I mean, if you know what a vertex is, it's a point, right? Whoops. Vertex, we know the vertex is going to be a point. And we know it's going to be 4 comma something. You guys agree with me? Right?
It's 10.
So how did you get that?
Here's the white.
So let's get rid of this stuff because that's not really the point. I was just using that as an example. So how do you find the y of the vertex? Who knows?
Oh, the C.
Alright.
The C. C, that's 10.
Okay, well wait a minute. Wait a minute. What is C again? It's the y-intercept. What is the point? Okay, what is the point? What is the x of a y-intercept? You can't have a, well, yeah, you can't have a y-intercept unless x equals 0. So the point for the y-intercept, this point, is 0 comma 10. I'm asking for what is y when x is 4, not when x is 0, right? You see the difference? So you're not looking at that number for finding the y of the vertex.
You go to the B.
You go, okay, yeah, to what? The original equation. So look, go back to your original equation. It says y equals. That's what I want. I want to know y equals, and then it has x squared minus 8x plus 10. Oh my God. I could plug in, I know what x is. X is 4. When x is 4, I could plug that in, and then I could find my y. Now, this is where people make mistakes, quite honestly, because they do it in their head. Not a good idea, right? It's really important to do this, right? Y is equal to, I'll just recopy the equation for a second. Minus 8x plus 10. So if I know my x is 4, I'm going to rewrite it as y is equal to 4 squared. I like to put my 4 in parentheses because if it had been a negative 4, then I would realize it's negative 4 that's squared. You know what I'm saying? In this case, it's positive. Anyways, minus 8 times 4 plus 10. You're much less likely to make a mistake if you write this part like this. Right? You follow me? Make sense? As opposed to saying, well, 4 squared is 16 and 8 times 4 is 24, right? That's what happens. People mess up, or they'll forget the signs or something. I don't know. It happens every day when people do it. So now it's so much easier, it's so much harder to make a mistake. It's easier to make it do it right. 4 squared is 16 minus 32 plus 10. Okay. Now what is 16 minus 32? Negative 16. That's interesting. This is a pattern that you're going to see a lot of. Okay? 16 minus 32 ends up to be negative 16. Interesting.
Plus
And then
10
plus
is
10.
-6.
So it's negative 6. Y is equal to negative 6. So my vertex is 4 comma negative 6. Now fist to 5. Do you guys understand how we got that? We used axis of symmetry to find my x of my vertex. We went over and drew my axis of symmetry at 4, right? Up and down, dotted line. And then I plugged that 4 in for x in my original equation. And that gave me my y. Does that make sense? You see it? All right. Now we have a vertex. Let's go plot it. So that's 4. This is 1, 2, 3, 4, 5, 6. So over 4, down 6, like there somewhere. Oh shoot, now I don't know what to do. I've got my vertex. What?
Standard parabola.
Standard parabola guy. Thank God for somebody. Okay, look at that. It's standard parabola guy. Now why am I just boxing this off? What about all this stuff? Well, we took care of it. We used this to find the vertex. Now that we're done with that, now we just have to do this. Standard parabola guy. It's not times 2. It's not 2x squared. It's not times a half. It's just standard parabola guy. So from here, I pretend that this vertex is my origin. Pretend, right? And I'm going to say, okay, over 1, up 1, put a dot. Over 2, up 4, put a dot. Over 1, up 1, put a dot. Over 2, up 4, put a dot. I don't know whether I'm doing these right. 1, 2, 3, 4. That's pretty good, right? And I just draw my parabola. Look at that. Easy. Piece of cake,
Yep.
right?
Okay, can we do the homework so we don't have to do any of the weekend, please?
Okay, we're going to do one more just to
Or
practice.
We have
Okay.
10 minutes, Arbor.
Can I erase? Do you want to take a picture? Why don't you take a picture so that you can see this part. This part in particular is what I want you to. Got it?
Got it.
All right, good. All right, so now I'm going to erase this. We're going to do one more. All right. Erase this. Oops. Okay, let's say we do. Let's say we do y is equal to. What do we do? Negative 2x squared plus 4x minus 2. I don't know how that's going. I don't know where that's going to take us for the y, but that's okay. We'll just sort of see what it is. So my first step is what?
Find the b.
Find the b, which is using the what's the name? Axis of Symmetry formula. X equals negative b over 2a, which is equal to, b is 4, so negative 4 over 2 times negative 2. All right, so I have negative 4 over negative 4. You guys agree with me?
1.
Which is equal to 1, right? That's going to be easy. So now I know that my vertex is 1 comma something. Now what's the next step I do?
So you plug that in.
What do I do with my axis symmetry first?
You draw a line.
Draw a line. It says it's at 1. My x is over at 1 right here. So it's going to be a vertical dotted line. And I know what about that? What do I know is on
That the vertex has to
the
be.
vertex is somewhere on that dotted line. And so now I'm going to what do I do?
X equals 1. Now plug it in.
Okay, plug it into this, right? So y is equal to, I'm going to just read it from there, negative 2 parenthesis 1 squared plus 4 times 1 minus 2.
It's
All right,
0.
so y is equal to negative 2 times 1 is negative 2 plus 4 minus 2. So 4, well, let's wait. Negative 2 plus 4 is 2. 2 minus 2 is 0. So y is equal to 0. So my vertex is at 1 comma 0. That's interesting. So 1 comma 0. So over here, I put it right here. Now what do I do?
Times 2.
Standard parabola
Negative
guy
2.
times
Negative
what?
2.
Negative 2,
Gary,
right?
I can't see what you.
All right, sorry.
Okay, negative 2.
Sorry.
Minus 2, like.
Right?
Negative.
Okay. So now I got to use standard parabola guy times negative 2. All right. Which means I'm going to start at my vertex, pretend that that is my origin, and I'm going to go, hang on, let me just draw my line. Okay. I'm going to do over 1, down 1 times 2, which is down 4. Or over 1, down 1, twice, right? I'll go over here, do the same thing, down twice, boom. Over 2, down 4, 1, 2, 3, 4, and then down 4 again. 1, 2, 3, 4, or something like that, right? And I know that the distance from here to here is the same as the distance from here to here. So I'll just put because I know it's symmetrical. So now I just draw it, and looky there. Isn't that great? Now, I guess, you know what? I wanted to show one last thing. And we're going to do it kind of fast, okay? Can I erase this? You guys got it? Okay. Because I just want to show you one last thing that sometimes gets confusing. Erase that. Oh, whatever. Erase the whole thing. Let's say I gave you something like this. Y is equal to x squared. All right, hang on a second. Let me think about this. No, never mind. I'm not going to go there. But let me just explain, because I can't make it up on the spot and have it work the way I want it. Maybe you could, but I can't figure it out. But if let's say this was my graph, right? And I found that my vertex was this. Let's just say it was. Let's say my vertex was 2, negative 4.5. Okay? So let's think about it. So over 2, down 1, 2, 3, 4.5. There's 5. It doesn't look very even okay. Okay. What did I say? 2, down 4. 1, 2, 3, 4.5. Okay? And let's say it was y equals x squared something, right? Well, I could have just done it without the b. That would have been fine. Doesn't matter. You got the idea. So, but notice, this is, well actually, I'm going to make it a b. Let's just do this. Y is equal to x squared minus 4.5. Okay? All right, I'm changing it. So now we know what our vertex is because there's no b, right? So now we're going to go down 1, 2, 3, 4.5. It's right there, right? Now what do I do? Over 1, up 1. But what is up 1? It's over 1, up 1, which is 3.5. Do you see that? That's the hard part. When they work out like this, where your vertex is not on a thing, you got to remember going up 1 does not mean going up. Doesn't mean going up to this. It means going up exactly 1. So if you're starting at a half, you got to go half and then another half, right? You follow me? See what I'm saying? And then over 2, up 4. So another half, another half, another half, another half. It would be right here. Whoops, right there. Sorry. Right? You see what I'm saying? Follow me? Right? That's where it gets a little tricky using the standard parabola-guide method. But it's not that bad. It's not that bad.
Okay.
Very quick. Okay, so I'm going to give you the homework and you can get started. Now, let me think. Let me just make sure I haven't forgotten anything.
Gary, don't forget to stop the recording.
Okay. Yeah, I think it's fine. Oh, uh-oh. It's red.
Does that mean?
It means it stopped. Okay, well, I don't know where it stopped. Oh, wait, no, it's supposed to be red.
Yeah, it's supposed to be red.
Sorry. I saw red and I thought